Hello everybody and welcome to another video. This video is going to be a continuation of the video titled C++ Hacking Destructors. So the objective, just to give you some context and some background, the objective for us in that video was to avoid a situation of an unnecessary destructor invocation or call if we are 100% sure that we're going to move a value out of the current scope or into another piece of memory. So, for example, what do I mean by that? So let's say we need to create a class and push it onto the vector. Let's say S1, and let's create a value, and I need to move that after I do some mutations here or process my S1 depending on my code logic, based on my code logic. So now if we take if we look at the output of this code, let me just turn that off for a moment, since we do need to keep the rest of this code for the video. So if we look at this, we initialize the S, which is fine. Then we move it, which is also fine because there's no other way. And we move it because the underlying implementation of pushback in a vector is essentially a new placement. So it's going to be new on our buffer, or rather like this. And then we pick up the move from that code logic. You can check out the source code of memory header and see it from yourself. I will include that link in the comment below or the video description. So the problem with this is I'm 100% sure I'm gonna move my variable out of the scope, but still I will have to call or invoke the destructor at the end of its lifetime or life cycle in this scope, or whichever scope it's defined in. So we talk about in some of the previous videos that primitives, they're not required to have destructors for the simple reason that is we don't need to invoke anything with a primitive. And for us in a class like this where I have something on heap, let's say, or I have a buffer on heap, but for the purposes of simplicity I made this an integer, even though you would just use an int, you wouldn't use int pointer in this case. But let's say I have something on heap where I need to check if that is a null or not. But if I move my value out of that scope, it is 100% going to be a null. So I don't need to call my destructor. Why would I need to call my destructor? So in that case, this pointer is considered a primitive, which is not in the need of a destructor. So I'm simply slowing down my code because I am calling an unnecessary constructor. And this is one of the problems that, one of the problems that could be huge problems of C++ programming language design, but that's neither here nor there. our approach to avoid this in the previous video was to use a union where a union disallows or disables the implicit call of destructors. So what I would do is, let me just modify this code. So what I would simply do with this is that I need to create a union. I need to call a move, a new replacement on it, and then I move it. And now I'm not calling the unnecessary destructor. But this code is just simply horrible, horrific, terrible. It's just not the kind of code you want to see in your code base. Because now each time I want to create a new variable, I have to define a new union, and I have to reuse it, and new placement here, and then move here. So even though I'm 100% sure I'm moving the value out of the scope, still this code is not really something we should prioritize in our code base. So I thought about this a bunch, and after making a video about the static storage in C++, I realized that I can have a custom buffer on stack that's not gonna have the destructors, the typical implicit destructors invoked at all. And this was a problem with something like this. So if you have an array on stack, it will call, or it would pre-fill all of the 100 elements of this buffer here. So in order to avoid and eliminate the just bottleneck of that would potentially, and I mean it will slow down our code at runtime. Why would I initialize elements that I don't need? So you would essentially create a lazy array like this that would allow you to add elements that you actually use. So I thought about that. So what if I can take this piece of code and say my buffer will be the size of my class, and then I'll be able to initialize it via placement new, which is simply just how we add an element to this lazy storage buffer or array, and just use that logic. Why not? So then I came up with something like this, where this code is much easier to write. You can even wrap it up in a macro. It won't be a problem, because in a macro you would, I don't know, define something like this. Let's say I want to define something uninitialized, or let's call this I don't know, just custom init. And then you would have the name of your variable, which will be the declaration name, and then you would have the type of it, and you would just do assigned character decl name size of t. And size of t is really safe to use in this case, because this size of is determined at compile time, and there is nothing insecure or really concerning about that. But also the problem with this implementation of a union was that you have to enforce a compiler, or rather force a compiler to do additional work, such as attribute always inline, where this is required of us to do, because if we don't do it, we will generate an error at compile time where a destructor of a union is implicitly deleted. And in order to avoid that, and in order to avoid the additional call of the destructor of the unit itself, we have to inline it. But that's really more work for our compiler. And also, I've seen online that some people would try to write a lambda. So, 1 second. They would try to write a lambda like this that would do the work in the function body that we would typically do somewhere here before we move this variable into another entity. While we are guaranteed to return an x value out of this because it's a function call and it's really copy elision, it still won't cut it. It will cut it for something like an array, which is a standard C++ container, but it will not cut something like a pushback of a vector. And oh, by the way, this doesn't change at all at any optimization level, so do not expect your compiler to take care of something like that. So while this approach is okay, it technically makes sense. If we look at the output, we haven't accomplished much at all, where we still need to call the destructor because the end of this R value ends here and it's treated as R value, which will be destructed or cleaned up via C++ RAII at the end of the semicolon. So we do not accomplish anything like this in this scenario, but it will work in an array or an initializer list, I'm sure. Let's check that out, by the way. Initializer list, where we have a list of process S. Now I will have to include it, most likely, no. Now it will work for these kind of arrays that are defined really on stack, or they're sort of a mirror of a static storage implementation that we talked about it in one of my videos. And if you have more interest in understanding the implementation details of initializer list and a high-level overview of how it also works and how to use it and when not to use it, check out the video called C++ initializer list implementation on my channel. So anyway, let's get back to our code here. Let me just define a vector like I did below, where I would push back and move my value out of the scope. So this will be a little bit of a trouble, since you have to do this kind of casting here. Because our buffer is really an unsigned character. So each time you would use your variable of S, you would need to do something like this. And that could be really a pickle or a pain in the neck or bottleneck, but it is what it is. You can wrap it up in a macro and you can pass it around with no concerns at all. And now what we've accomplished here is that we call the constructor, which is fine, we call the move, which is fine, and we call only one destructor. And that is the cleanup of the vector. So that's the destructor of the vector that we are calling. So that's fine 100%. And now we have removed, or we eliminated the extra destructor call just like that. And also one of the videos that are worth checking out is advanced memory allocation in C++, where we talk about unsigned character and where we are using it for both on heap and on stack lazy allocations. So yeah, this to conclude and wrap up this video. It's much better to use unsigned character like this than to have a union, a wrapped up union that's really not something we should necessarily be prioritizing in our code base. And I mean, nobody really would do something like this, and something that's that creates a just difficulty to read your code or understand your code. But this kind of code here would be much cleaner, and also we are not forcing the compiler to do more work on the union, such as initializing this destructor, and more so trying to parse and compile our union before it's even used. So it's better probably on every level conceivable to use an unsigned character allocation. Alright, that would be all for this video. I hope you find this useful. And oh, by the way, let's check if we are causing any memory allocations here, just to prove the point that this is 100% safe to use. So I'll just create main2 and let's do this, shall we? I'll use valgrind as per usual. Now I could have made some mistake in the code, but let's just make sure. Yeah, I definitely did. Let's see where it is. Yeah, it's definitely here. So let's comment this code out since we don't need it. I just left it there for demonstration purposes, but now that we don't need that piece of code, we are all good. No leaks are possible. So now that would be all for this video. Thank you so much for watching, and check out some of my other videos and check out the source code of this video in the description below. Thank you very much and take care.